Would you believe it if we told you that one day there could be batteries that can last for an eternity? And by an eternity, we mean 28,000 years. Nuclear diamond batteries open up a whole different realm where the possibilities are endless. Keep watching to find out how the richest man in the world, Elon Musk, aims to incorporate this technology into his EV manufacturing company, Tesla, converting nuclear waste into an energy source that lasts for 28,000 years. Sounds like something out of a sci-fi movie, right? Well, it is very real. A tech startup based in California, Nano Diamond Battery NDB, has been working to develop these nuclear diamond batteries for the past several years now, and it sounds like they might have finally done it. The company claims it will start selling the battery to its commercial partners within the next 2 years, while also rolling out a consumer version that can power smartphones for over a decade. Not exactly 28,000 years, but hey, can't complain about not having to charge your phone for the next 10 years. The diamond battery will also be a big boost to space and rocket technology, where it can be used to power the space vehicles as they travel for millions of miles in the universe. These batteries may one day power satellites, providing them with enough spare energy to deorbit till the end of their lives, or probes heading into deep space for thousands of years. It will particularly be very helpful to Elon Musk's SpaceX, which has a mission of transporting humans and payloads to Mars by 2029. NASA spacecrafts are powered by a nuclear battery known as a radioactive thermoelectric generator, or RTG. Batteries for implantable medical devices, or IMDs, must perform for an extended period without needing to be recharged or maintained, and the size and weight should be kept to a minimum. During the 1970s, nuclear batteries known as beta-voltaic cells were commonly employed in IMD. However, the possible risk of radiation prompted to move to lithium-ion batteries in the 1980s. The usage of beta-voltaic cells is being reassessed in light of recent advances in nuclear batteries. The diamond batteries are a perfect replacement for the lithium-ion batteries that are being developed by Tesla and used in most other EV brands. Lithium-ion batteries only give an EV car a range of about 500 miles, but with nuclear diamond batteries, your car will be able to drive for several days without a charge. However, the Nano Diamond Battery Company is yet to reveal the price of the battery since it is in the development stage. The technology used to create these batteries is complex. The technology involves combining radioactive isotopes taken from nuclear waste with layers of nanodiamonds stacked into a battery cell. Medical devices that remain in your body for long periods of time, such as hearing aids and pacemakers, can benefit from the diamond batteries given that they can produce energy for extended periods. The batteries are used to power machines that consistently require a small amount of power that is produced over long periods. The system works by adding diamond layers and radioactive waste panels to increase the output. One thing that scientists admire about the batteries is that it takes nuclear energy, something perceived as a negative element, and converts it into something good. This should be appreciated given that nuclear energy can be used to wreak havoc, as in a situation where it is used to make nuclear weapons. As we mentioned, it is safe as it has a strong material that people cannot penetrate to access the power cells. It also has a coating of polycrystal material which is highly dense and is able to contain all radiation. In fact, it is 12 times denser than steel. As such, these batteries are considered incredibly safe. Every element we know of produces a certain level of radioactive energy, even our bodies. Early results of testing suggest that these new batteries produce even less radioactivity than our bodies. The NDB system uses diamonds, which are extremely good conductors of electricity and makes a good target for electronic devices. In fact, their rate of conduction is 4 times that of steel. Scientists cultivate these miniature diamonds using chemical vapor deposition, a process in which gases at extremely high temperatures force carbon to crystallize on a substrate material. That process, NDB admits, creates a cost bottleneck, making this process expensive as of now. When enough of these diamond battery cells are combined, they might still power high-energy demanding gadgets on Earth, such as LED displays on tablets and mobile phones. NDB, on the other hand, intends to produce smartwatches as its very first commercial product, with the launch date set for 2022. If this is true, you could possess a single watch with a single battery and pass pass it down for generations without having to replace it. Talk about an heirloom. The battery is made up of two types of nanodiamonds and produces its own charge instead of storing energy generated elsewhere, making it almost crash-proof if used in cars or other moving things. The diamond battery is beta-voltaic, which is similar to photovoltaic solar cells, but it converts beta radiation as opposed to light into electrical energy. It is manufactured using the process of chemical vapor deposition, which uses C14 methane and hydrogen plasma to grow diamond fumes at high temperatures. The nuclear waste from which NDB plans to make its batteries are reactor parts that have become radioactive due to exposure to nuclear plant fuel rods. While not considered high-grade nuclear waste, it's still very toxic, and there's a lot of it in a nuclear generator. The firm also anticipates their batteries to be competitive prices compared to current batteries such as lithium-ion, and possibly even cheaper once they're mass-produced. Nuclear power plants currently have a huge problem. When producing nuclear energy, a byproduct of nuclear waste is created. Getting rid of this waste is not an easy task, and the solution so far has been to bury it covered in steel and concrete. It is expected that these nuclear plants will pay nuclear diamond battery companies to take their nuclear waste and utilize it in their batteries, thus reducing the cost of these batteries significantly. Dr. Tom Scott's research at Uni of Bristol focuses on understanding the fundamental and changing properties of materials in a variety of artificial and natural contexts in order to better predict their performance and develop techniques for improving it. He spent a lot of time researching on the behalf of the nuclear power sector. He is the technical director of IMI Tech Limited, a spin-off firm that specializes in detecting and mapping radioactive elements in industrial, urban, and environmental sectors. When exposed to tremendous pressure deep inside the Earth's crust, natural diamonds, which are totally carbon, require hundreds of thousands to millions of years to develop. There is no radioactive carbon in these. Artificial diamonds are made with a good natural carbon source such as graphene and a high-pressure machine. They don't, however, contain radioactive material. Radioactive C14 isotopes, which are known to be the greatest radioactive waste by volume, are used to make radioactive man-made diamonds for use in diamond batteries. From a functional aspect, a diamond battery is similar to the radioisotope electro generators used in space probes and rovers. The diamond battery generates electric charge by direct energy conversion using a semiconductor diode and C14 as a radioisotope source. When compared to other options, the power output of these diamond cells is low. However, because of their overall lifespan, they are likely to become important components in future electronics manufacturing. It is possible to turn a long-term serious problem of nuclear waste management into a nuclear-powered battery for a long-time supply of clean energy by encapsulating radioactive materials inside diamonds. The cost of creating an artificial diamond is substantially lower than the expense of removing used nuclear fields and nuclear waste from the environment. Despite efforts, it is estimated that by 2023, the United States will only have enough radioactive fuel to power 2.5 nuclear battery modules per year. There is no doubt that the nuclear diamond batteries are the future.